In this video, we are going to discuss about the Schottky barrier diode, Zener diode, and the Varactor diode. Schottky barrier diode is also called as hot carrier diode. In the recent years, there have been a very interesting increase. That is, it consists of the two-terminal device, which is referred to as the Schottky barrier, surface barrier, or hot carrier diode. Actually, this is very used in the recent times only, and also its area of application is actually in the range of high frequency range, and it has a lower noise figure. So in the recent days, this is appearing more and more in voltage, low voltage, high current power supplies, and AC to DC converters. The major applications are it is used in the high frequency ranges. So you can see the cathode terminal metal contact metal semiconductor junction, and above it has been placed a silicon diode dioxide screen, and above that it has a metal which has a golden leaf metal contact. And here its construction is actually different from the conventional PN junction. That is, this Schottky diode is having a metal semiconductor junction, and it is normally doped with the N-type silicon. That is almost P-type silicon is sometimes used in the middle of the region, while the host of the other different metals such as molybdenum, platinum, chrome, or tungstens are also used instead of the silicon. Different construction techniques will result in different set of characteristics, and also this occurs only in the increased frequency range. The major priorities are it does not permit an examination of every technique, and also this information will be used and it is provided by the manufacturer, which results in a more uniform junction region and a high level of ruggedness. In both the materials, actually the electron is the majority carrier and the level of the minority carriers is also significant. When these materials are joined, the electrons in the N-type silicon semiconductor immediately flows to the adjoining material, and it forms the heavy flow of the majority carriers. Since these injected carriers have very high kinetic energy level, they are commonly called as the hot carriers. In addition to this, there is a negative wall which is kept in the boundary between the two materials, and the net result of these surface barriers between the two materials will prevent the flow of current from flowing into it. That is why any electrons in the silicon material will face a charge free region and also a negative wall at the surface of the metal. And the next one is the Zener diode. The Zener diode is a type of the diode that permits current not only in the forward direction like a normal diode, but also in the reverse direction also. Hence this voltage is larger than the breakdown voltage. We call that as a knee voltage or Zener voltage. And the diode symbol is shown here. So here this breakdown diode is also called as Zener diode, and this is basically used in the standard PN junction diode that is basically designed to have the low predetermined reverse breakdown voltage, which is having the advantage of this high reverse voltage. And this Zener diode is like the general purpose signal diode consisting of silicon PN junction. When the bias is in the forward direction, it behaves just like a normal signal diode passing the rated current, but when the reverse voltage is applied in the reverse saturation current, it remains fairly constant over a wide range of voltages. The point at which the current flows can be accurately controlled to the doping stage of the diodes. It can be to few volts or few hundred volts. You can see the Zener diode characteristics. When you are applying the high voltages at a particular point, it goes to the reverse region and it gets increases. That region we call it as the Zener breakdown voltage. And this Zener diode can be used as a regulator because it has the stabilized voltage output, and also it produces the very low ripples in the case of the varying loads also. So when you are passing some small current through the diode from the voltage source, a suitable current which is limiting the Zener diode will conduct the sufficient current to maintain through the voltage volt, and also it produces small ripples. Varactor diode is also called as a variable capacitor. Here the junction capacitance will be in the reverse biased, and the junction capacitance is optimized in the varactor diode, and it can be operated only in the form of the high frequencies and can be used in the form of the switching capacitances. You can see the depletion region in reverse biased region, and the circuit symbol. So this is also called as voltage variable capacitance diode. This junction diode acts as a variable capacitor under the changing reversing bias, and the formulas are given. CT is equal to summation A divided by WD. Thank you.